All right, this is just a very quick set of review notes. This is something that you learned in seventh grade, possibly before then. But if you noticed those nets that you cut out, they had one thing in common. They were all circles or sphere. Well, they all had a circle or a sphere as part of them. There was a cone, a cylinder, and a sphere. So circles were involved all the way. So we're going to be using these formulas a lot right now. So first we're going to review some terminology. Point A, that point right there, that is the what of the circle. That's the center of the circle. You could have probably figured that out without me. Let's label that here too. It's the center of the circle. Another piece of vocabulary. A chord is a line segment that joins 2 points on the circumference of a circle. So circumference is the distance around. So what do we have that joins 2 points that are both on their circumference? This doesn't, because that goes from the circumference to the center. This does, but we're going to save that. That's a special chord we're going to get to. And so this one right here also does. And so that's the chord. Let's go ahead and label that one. That's our chord. Again, these are both chords, but we're just going to label this one. Finally, for this part, the diameter of a circle is any straight line segment that passes through the center of the circle and whose endpoints lie on the circle. It is the longest chord of a circle. So this right here is our diameter. Let's label that. All right. I know I kind of had to cut and paste mine to look a little bit different from yours, but you get the idea. Okay. The radius of a circle is the distance from the center point to the edge of the circle. It's the same distance anywhere on the circle. So this right here, that's our radius. And if you think about it, if it sat here in the center point, and we changed this to any other point on the outside, it would still be the same. Same thing happens with the diameter. No matter how we spin it around, because of the rules that we have, this is always going to be the same length. That's not true for a chord, because a chord you could change endpoints all over the place, right? Okay. All right, and then we have the diameter is twice the length of the radius. Well, of course, because if the radius is just from the center point to a part of the circumference, and the diameter goes from the circumference to the center point to another end on the circumference, and it's a straight line, it's got to be twice the length of the radius. So if we think about it, what's the diameter of a circle whose radius is 2.5 inches? Twice that. That's going to be 5 inches. All right, let's move along. You can calculate the area of a circle by using the formula A equals pi r squared. Pi, as you probably know, is the symbol used to represent a constant, 3.1415, but more importantly, what you really should know is that it does represent the ratio of the circumference of a circle to its diameter. So it really is a ratio. That's why it's also referred to sometimes as 22/7, because that's the ratio that ends up happening. But we're not going to worry about that. All right, so we can approximate it as 3.14159, or most of the time we'll just say 3.14. All right, so let's use that. What is the area of the circle shown below? Well, the formula is A equals pi r squared. Well, we're going to use 3.14 for pi, so let's plug that in. So A is about. I'm going to switch to about, because once we go from the symbol to 3.14 or any number for pi, because the number goes on forever and we're not going to, we're going to switch to the about symbol. 3.14 times r squared. What's the radius? 7. So 7 squared. And now we just need to do the math on that. A is about 3.14 times 7 squared is 49. And then calculate that on a piece of scratch paper. We'll get A is about 153.86 inches squared. Why squared? Because we're talking about area. That's a two-dimensional thing. If we filled this up with lots of squares, what would we get? All right. You can calculate the circumference. That's the distance around a circle by using the formula c equals 2 pi r. Or, well, because we know that the diameter is twice the length of a radius, we can just take that out and say it's equal to pi d. Either one works. What are you given? If you know this one, you can figure out this one. All right, let's use that. The circumference, remember, is the distance around a circle. So if we put an ant on here, it goes all the way around. So is that going to be inches squared? No, it's just going to be inches because it's like a string. Okay, what's the circumference of this? Well, what's our formula? C equals 2 pi r. Plug in what we know. So C equals 2 times pi times 7 because our radius is 7. So C is about. I switched to about because we're about to replace pi with a number. While we do that, we can say, well, 2 times 7 is 14. Let's try that again. That's 14. There we go. Times, and we'll plug in 3.14 for pi. And now we can just multiply that out, and we'll get C is about 43.96 inches. Remember, not inches squared because we're talking about a distance, not an area. All right, so you have all the information you need for tonight's homework. Well, which really isn't tonight's homework. It's your homework for the next week. You have a week to get it done, plus today's class. Well, I'm guessing you probably weren't here if you're watching this. Whatever. I'll see you next class. Have a good one.